NEC 2002 does not specifically address the use of a neutral from a different source to power a motor control panel connected to a buck-boost transformer. However, there are general NEC requirements that must be met. Article 430, that is 430.1 through 430.20, covers motors, motor circuits, and controllers. This article requires that all motor controllers be properly rated and protected. This includes proper overload protection, short-circuit protection, and disconnecting means. The motor controller must be suitable for the voltage, current, and horsepower of the motor it controls. Article 440, that is 440.1 through 440.60, pertains to transformers. This article requires that transformers be properly installed and connected to provide the correct voltages and currents. The transformer must be sized appropriately for the load it will serve and must be protected from overcurrent. The neutral must be correctly sized and protected according to the current draw of the motor control panel. This involves calculating the total current the motor control panel will draw under normal operating conditions. The neutral conductor must have an ampacity equal to or greater than this calculated current. Overcurrent protection, such as a fuse or circuit breaker, must be provided to protect the neutral conductor from overload. The phase wire from the boost transformer must be properly sized and protected for the motor current. This involves calculating the full load current of the motor and selecting a conductor with an ampacity equal to or greater than this current. Overcurrent protection must be provided to protect the phase conductor from overload and short circuit. The neutral and phase wires should be properly identified to avoid confusion. This can be achieved by using color-coded conductors or by labeling the wires at each termination point. Proper identification of the wires is essential for safety and for ensuring correct connections. Ensure that the boost transformer is properly grounded. Grounding provides a low impedance path for fault current to return to the source, which helps to protect personnel and equipment from electrical shock. The grounding system must comply with the requirements of NEC Article 250, that is 250.1 through 250.198. Verify that the motor control panel is properly fused to protect the motor and the transformer. Fuses or circuit breakers are used to protect electrical equipment from overcurrent. Fuses or circuit breakers must be sized appropriately for the equipment they protect and must be of the correct type. Use insulated wire and proper wiring methods to prevent accidental contact with live wires. Insulated wire is designed to prevent electrical shock. Proper wiring methods, such as using conduit or cable trays, help to protect the wires from damage. While there is no specific NEC provision that prohibits using a neutral from a different source for a motor control panel connected to a buck-boost transformer, it is important to ensure that all the necessary NEC requirements are met to ensure safe and proper operation. This includes proper sizing, protection, and identification of the wires. It is also recommended to consult with a qualified electrician to ensure compliance with all applicable codes and standards. Understanding buck-boost transformers is crucial in situations where the available voltage supply does not match the voltage requirements of the equipment being powered. In this case, a 240-volt surge pump motor needs to be powered from a 208-volt single-phase source. A buck-boost transformer can be used to either step up or step down the voltage to match the required voltage. The key here is to ensure that the transformer is properly sized for the load and that all wiring and connections are made in accordance with the National Electrical Code (NEC). The motor control panel typically requires a 120 volts power supply for its operation. This raises a critical question: can the neutral required for the motor control panel be sourced from the 208 volts 3-wire source which feeds the panel board, while the phase is taken from the output leg of the buck-boost transformer? According to the pump manufacturer's technical expert, this is how the internal wiring is designed within the pump control panel. While this might be the manufacturer's design, it is essential to verify whether this configuration complies with the NEC and ensures safe operation. Firstly, let's consider the relevant NEC articles. As mentioned earlier, Article 430, that is 430.1 through 430.20, covers motors, motor circuits, and controllers. This article provides guidelines for the proper installation and protection of motors and their control equipment. Article 450, that is, 450.1 through 450.60 covers transformers, including buck-boost transformers. This article outlines the requirements for transformer installation, overcurrent protection, and grounding. Now let's delve into the wiring considerations. The neutral conductor must be correctly sized and protected based on the current draw of the motor control panel. This involves calculating the total current that the control panel will draw under normal operating conditions. The neutral conductor must have an ampacity equal to or greater than this calculated current. Overcurrent protection, such as a fuse or circuit breaker, must be provided to protect the neutral conductor from overload. Phase wire from the buck-boost transformer must also be properly sized and protected for the motor current. This involves calculating the full load current of the motor and selecting a conductor with an ampacity equal to or greater than this current. Overcurrent protection must be provided to protect the phase conductor from overload and short circuit. Proper identification of the neutral and phase wires is crucial to avoid confusion and ensure safe connections. Color-coded conductors or labeling at each termination point can help with this. Additionally, ensure that the buck-boost transformer is properly grounded in accordance with NEC Article 250, that is 250.1 through 250.198. Grounding provides a low impedance path for fault current to return to the source, thereby minimizing the risk of electrical shock. Verify that the motor control panel is properly fused to protect the motor in the transformer. Fuses or circuit breakers should be sized appropriately for the equipment they protect and should be of the correct type. Insulated wire and proper wiring methods, such as using conduit or cable trays, should be used to prevent accidental contact with live wires and protect the wires from damage. The configuration of using a neutral from the 208 volt source while the phase is taken from the buck-boost transformer's output could potentially violate NEC if not done correctly. Here are some key points to consider. Firstly, the NEC generally requires that the neutral and phase conductors for a particular circuit originate from the same source. Mixing neutrals from different sources can lead to circulating currents and potentially create a hazardous situation. Secondly, the impedance of the neutral conductor can affect the performance of ground fault protection devices. If the neutral is not properly sized or if it has excessive impedance, it can prevent these devices from operating correctly. Thirdly, the voltage drop on the neutral conductor can affect the voltage supplied to the motor control panel. If the voltage drop is too high, it can cause the control panel to malfunction. To ensure compliance with the NEC and to avoid potential safety hazards, it is highly recommended to consult with a qualified electrician. A qualified electrician can assess the specific installation conditions and determine whether the proposed configuration meets all applicable codes and standards. They can also perform calculations to ensure that the conductors are properly sized and protected and that the grounding system is adequate. Furthermore, they can advise on any necessary modifications or alternative wiring methods to ensure a safe and reliable installation. In conclusion, while the pump manufacturer's technical expert may have suggested a particular wiring configuration, it is crucial to verify that this configuration complies with the NEC and ensures safe operation. Consulting with a qualified electrician is essential to ensure compliance and to avoid potential safety hazards.